Okay, we are still on this practice page, but now we're going to talk about our negative exponents. Now this is just a brief review of our negative exponents. So our first example is x to the negative third power, and we are going to be rewriting with positive exponents only. So we know that in order to make a negative exponent become positive, we need to move it. We need to either move it up or we need to move it down. In this case, our negative exponent is in the numerator because we know that all fractions have at least a 1 in the denominator. So this is in the numerator. We need to make this negative 3 positive, so we need to drop x to the negative third down into the denominator to make it become a positive 3. So our placeholder 1 is going to stay in the numerator. X to the negative 3 drops down. When it drops down, it becomes positive. So x to the negative third power is equal to 1 over x to the third power. Let's look at example 2. 3x to the negative second y. There are 3 factors in this problem. We have 3, we have x to the negative second, and we have y. So what we want to do is rewrite that so all of our parts are separated so we can clearly see them. We have 3 times x to the negative second times y. There is one negative exponent here. That one negative exponent is what needs to go into the denominator. So the only thing going down into the denominator is going to be x to the negative second. That's going down into the denominator so it can become positive. So we are left with 3 in the numerator. Our x to the negative second comes down and becomes x to the positive second, and then we still have y in the numerator. So your final answer, 3y over x squared. 3y over x squared. So this is how you rewrite negative exponents so they can be positive exponents. Now you are going to do the pink problems. The pink problems. Remember the ones we did in the other video? We have 2 problems that have negative exponents in it. Our final answer for number 17 was 3w to the negative 5th power. Now before I do this problem, you are going to do this problem based on the examples that we just did. Please rewrite 3w to the negative 5th power using only positive exponents. Let's go over your answer to see if you were correct. So we started with 3w to the 5th power. That's right over here. I want to separate it, so I have very clearly 3 times w to the 5th power. 3 does not have a negative exponent, but w to the negative 5th does. 3 gets to stay put, while w to the negative 5th goes down into the denominator. So our final answer is 3 over w to the 5th power. 3 over w to the 5th power. If you don't have this written down in your notes, please write it down in your notes. The other pink problem that I mentioned we would be revisiting is number 25. The answer we got for number 25 was 19k to the negative 26th power. So I would like you to rewrite this problem using only positive exponents. I'm sure you got that one exactly correct, but let's just go over it just to make sure. We started with 19k to the negative 26th power, and we separate our 19 from our k, so we can clearly see our 19 times k to the negative 26th power. 19 has no negative exponents, so it stays in our numerator, but k to the negative 26th needs to become positive, so we drop it down into the denominator, giving us a final answer of 19 over k to the 26th power. 19 over k to the 26th power is your final answer. If you do not have this work written in your notebook or your OneNote, please write this work in your notebook or your OneNote. Now I need you to show me what you have learned. Please do number 3. Rewrite 9 to the negative 7th power using only positive exponents. Next one, please rewrite m to the 4th, n to the negative 2nd power using only positive exponents. Now let's move on to our second set of negative exponent rules. We can also rewrite expressions without a fraction bar. Our first example is 5x over y to the 6th power. If you remember from our first examples, when we move negative exponents down into the denominator, they become positive. So that means if we have to get rid of this fraction bar, we have to move the denominator back up. That means it's going to become negative again. It's going to become negative again. 5x hasn't moved. 5x stayed the first time. 5x is going to stay now. But we need to bring y to the 6th power up to the numerator. That means y to the 6th power becomes y to the negative 6th power again. When you bring it up from the denominator, it becomes negative. You're getting rid of that fraction bar, so we need to bring the denominator up to the numerator, which causes the exponent to become negative. Example 4 is very similar. We have x to the 3rd over z to the 5th power. We need to bring z to the 5th up to the numerator, which means z to the 5th power becomes z to the negative 5th power. X to the 3rd stays put. Z to the 5th comes back up and becomes z to the negative 5th, making our final answer x to the 3rd, z to the negative 5th. We are doing 11, 12, and 13, but we are going to do number 12 together. Please write this down. Number 12 says 6z over y to the 5th power. 6z over y to the 5th power. Our goal is to rewrite this expression without a fraction bar. We need to get rid of this fraction bar. That means the number in the denominator needs to go back up into the numerator. He's down in the denominator because he was negative and we needed him positive. Now we need him back negative so he can come back up to the numerator. 6z hasn't moved, stays exactly where it is. Y to the 5th power needs to come up to the numerator, which means it's going to become y to the negative 5th power. Now I would like you to do number 11. Great. Next, number 13.